So inside the optical fiber, the communication can be done only if it is satisfy the total internal reflection condition. So what is mean by total internal reflection mean? This is a incident ray. So this is an incident ray. The ray which is incident on the surface is known as a incident ray. It will be create some angle with the surface, that is pi 1. This is known as a incident angle, and the ray gets diffracted into the another direction. The refracted ray similarly creates an angle with the surface, that is pi 2. So here pi 1 is the incident angle and pi 2 is the refractive angle. So the total internal reflection means the incident angle will be equal to the reflectance angle. So this is called as a total internal reflection, that is pi 1 is equal to pi 2. So this is known as total internal reflection, TIR. So usually the optical fiber cable consisting of 3 layers, that is core, cladding and puffer coating. So here core is the innermost layer which have the radius of A. Usually the optical fiber communication cables are in the cylindrical shape. So cylindrical means it is in the circular shape. So it has a radius and diameter. So here core has a radius of A and the refractive index of N1. Cladding has a refractive index of N2. So for the necessary condition for total internal reflection is the cladding refractive index is always less than the core refractive index. So here the fiber core is usually made up of silica glass and the fiber cladding is made up of glass or plastic fibers, and final one, the puffer coating will be made up of plastic jacket. So why we go for optical fiber communication means, as I told already, we can able to send the signals or light rays over the long distance. So that's why here the optical fiber communication is much needed or useful in the communication field. So here the optical fiber communication width is like a human hair, and it can carry the 5 lakh circuits of information at a time. So this is the advantages and disadvantages of the optical fiber communication. The advantages are it has a lead attenuation, greater safety and no crosstalk, higher security, less corrosion, less temperature sensitive and small in size, lightweight. The disadvantages of the optical fiber communications are the installation cost is very much high. The next one, only we can able to communicate a point-to-point communication, and the splicing is time consuming. Splicing is nothing but the connections between two fiber cable. The next point is it accepts only unipolar codes. So these are all the advantages and disadvantages of the fiber optic communication. In university exams, if they ask you to write about the fiber optic communication with a block diagram, means you have to explain about the block diagram representation, and then finally you can end with the advantages and disadvantages and applications. So the fiber optic communication applications are, it can be used in the telecommunication, video transmission, broadband services, high EMI areas, military applications and non-communication fiber optics. So the next topic is, in the fiber optic communication, it has some laws or conditions to propagate the wave to the receiver. So the first condition is, so before that, the law of the optics will be also known as a ray theory. That means the condition which is in the optical fiber communications or laws which is applicable in the optical fiber communication are known as a ray theory. This is an important questions. In the ray theory, we are going to learn about the reflection, refraction, numerical aperture, acceptance angle, and refractive index. These topics we are going to discuss about in the ray theory transmission. The first one, reflection. I think you are all know familiar in this reflection. Example, let us consider the mirror. If you are if you are passing the light in the mirror, means it will reflect back. So reflected means the incident ray, when it reaches to the surface, it gets reflected back to the surfaces. So in the reflection angle, the incident ray will be incident on the surfaces and it creates the angle of theta I, and it gets refracted or reflected back, that the angle is known as a theta or reflected ray. So here the angle of incidence is always equal to the angle of reflected. So in the fiber optic cable, the wave will be propagate like that. So next one, refraction. So refraction means when the wave passes through the less dense medium to the more dense medium, the wave gets refracted. Refracted means it gets bent, or it will be going through, or it can change the direction from the incident ray. So this is known as the refraction. Next one, refractive index. So the refractive index is the measure of bending of a light ray when it is passes from one medium to the other medium. Here the word medium is nothing but in which place the wave or light is propagated. This is known as a medium. Example, we can consider air, water, silica glass, and like that we can consider as a medium, diamond, like that. So here refractive index is nothing but the bending of a light ray when it passes from one medium to the another medium. And we can also say it can be defined as the ratio of velocity of light in the air to the speed of light in the medium. So that is c by v, that is speed of light in air to the speed of light in medium. So here I gave some refractive index for different mediums. For air, the refractive index is 1.0, for water 1.3, the diamond 2.417, for ice 1.31. The next one, Snell's law. This is an important law. So according to the Snell's law,